Well, good evening again, everyone. Welcome to our last WIMBA session for the semester. The goal tonight is to discuss Chapter 3 in order to get you ready for the homework that is due this upcoming weekend. It'll be your last homework assignment. And then next week will be the final exam, and then your projects will be due the following Saturday. So, Chapter 3 is all about project management. And first of all, projects represent a special type of network. They typically are very complex networks. Typically, you do them once. And so, as an example, it could be, a new product rollout. It could be a new marketing campaign. It could be a new product of some sort or a service, that kind of thing. The second thing about them is that a lot, when you're working in management in the business world, typically nobody gives you a list of all the things that need to be done. That's usually what they hire you for. And so in order to find out what are all the things that need to be done, there's something called a work breakdown structure. And work breakdown structures, just think of them as a list of everything that needs to be done in some sort of a sequential list. All right, and typically when a project team is formed, the project manager will have like a brainstorming session with their entire team, and then they'll use like those little sticky notes to generate not only all the tasks and activities that all the members think need to be done, but they'll try to put them in some sort of a sequence and then estimate how long it'll take, etc. And so that's basically what a work breakdown structure is. The book provides us with all the activities and the sequencing and everything like that. So we don't have to worry about that to do the homework. However, I did want to mention it since it is something that, from a practical perspective, is important. We're going to represent projects with networks, and networks are like processes. They have nodes and arcs, and so we're going to use the activity on node representation of our networks. So each node or circle will represent an activity that needs to be done. And then the arrows or the arcs will indicate the order that the activities need to be done. We won't really need to worry about dummy activities because we're not going to be dealing with activity on arrows, and that's pretty much something that is specific to that type of convention. So I wouldn't worry about that fourth bullet point. The critical path is the longest path through a network, longest being the total amount of time is the longest. And so we're interested in the critical path because that's going to dictate how quickly the project can be completed. So to complete the project, you have to complete all the activities in the network, and the longest path through all the activities is called the critical path. And then the last thing that we're going to talk about this evening is something called crashing. And in a project management perspective, crashing is shortening the overall length of a project by allocating extra resources to it. Okay, so any question? This is kind of more of an overview slide, but any question on the slide or anything that I covered? Okay, so there are 6 skill sets to be mastered in Chapter 3, and I've identified them, and we're going to actually practice all 6 of them. Well, we're going to practice 5 of them. I'll give you an example of the third one, the work breakdown structure. But the first one is, the first 2 are what I would call drawing a network and just doing basic analysis. And so drawing a network diagram and then identifying the path durations, critical path, and all that, that is what I would call project analysis. The third and fourth one are more interesting from a practical standpoint. The fifth one is we are going to move from a deterministic model in terms of assuming that all of our activity times are fixed and don't vary. And in number 5 there, we're going to assume that they do vary and they are distributed in a bell-shaped curve. And so we're going to actually deal with probabilistic activity times. And then the last skill set is to, construct a crashing table and try to optimize the amount of crash time that's needed. And that'll either be given in the problem or you'll have to find what the optimum crash length is. Okay, so again, what we're going to talk about this evening are outlined in those 6 items there. And if you understand those 6 items, you should be able to do the homework without any issues. Knock on wood. So any questions on this slide? Okay, so let's talk about, let's do an example here. And let's say that there's a student, Chris, who received new word processing software for her birthday. And she also received some money with which she plans to buy a new PC. Chris plans to use the new software and the new PC to write a paper that's due next week. And so Chris has actually made life easy for you guys. She's identified all the activities and how long it'll take each one, and as well as the sequence. So, for instance, activity A is shopping for a new computer, and there is no immediate predecessor. That's what the IP stands for. There's no immediate predecessor to A, and so A is going to, start the network. That's the first thing she's going to do, and she estimates that it's going to take 2 hours. Okay, so using this example, okay, let's go to the next slide. What we can do is we can identify and do like a work breakdown structure. That's what WBS is, where WBS identifies kind of the key themes that you can group all the activities in. And one of the themes is activities related to the PC. So that would include shopping for it, buying it, installing the software. And then the other theme is the paper. And so the activities around doing the paper would be, searching a topic, doing an outline, writing it, and doing a grammar check, and then submitting it. Okay, so again, this is an example of a work breakdown structure. So if you didn't have the slide, the previous slide, and if Chris hadn't, identified all those activities and the amount of time, what she probably would do is, generate a work breakdown structure like this, and then, okay, these are all the activities. I have activities associated with the PC and activities associated with the paper. How long are each of these going to take, and how do they relate to one another, sequentially? Okay, so this is an example of a work breakdown structure. Any questions or comments on this? Okay, so let's see if we can draw the network. All right, so this is sort of trial and error. So what you would do is you would look for any tasks that do not have an immediate predecessor. And the 2 tasks that do not have an immediate predecessor are task A and task D. All right, so the first tasks I'm going to put here are A and D. And you can see, task A has no immediate predecessor and task D has nothing before it. Okay, the immediate predecessor to task B is task A. So task B follows task A. All right, and so we would put B here. And then C comes after B. All right, so then I would draw an arrow here, and I'd put a circle, and I draw. Okay. And then after D comes E. So again, then I'm going to come down here and then I'm going to draw an E. And it's kind of a sloppy looking E, my apologies. And then after the E, D follows E. I'm sorry, E follows D. And then F follows C and E. So what I'm going to do here is I'm going to draw an F here, and then I'm going to draw arrows from C and E into F. And then G follows F, and then H follows G. All right, so this is an example of how you would draw a network diagram when you're given a chart that indicates, you know, the activities in the immediate predecessors. Okay, so any questions on how to, you know, read a table and draw a network when you're given immediate predecessors? Okay, so the second thing there, it wants you to identify all the paths. So to do this, you just work along the arrows until you identify each unique path. So the first one, the north route there, is A, B, C, F, G, H. And then the southern route there is D, E, F, G, H. Okay? And so once we identify the paths, then you can identify the durations. And the durations are just going to be the sum of the times for the path activity. So for the first path, activity A is 2 hours, activity B is 1 hour, activity C is 0.8, and then activity F is 3 hours, activity G is 0.5 hours, and activity H is 0.2 hours. And so if you add up all those times, let's see, you get 3, 3.8, 6.8, 7, 7.5 hours for the first, that northern path, A, B, C, F, G, H. And then for the southern path, again, you're going to just add up the time. So activity D is going to be 2. Activity E is going to be 0.4. Activity F is 3. And then G is 0.5. And then H is 0.2. All right, so if you add all those up, you get 5, 5.9, looks like 6.1 hours. And I hope I did the math right there. Let me know if I didn't. So 6.1 hours. All right, so when you look at how long it's going to take to get the entire network done, it's going to take 7.5 hours. And so the critical path is the longest path. And so in this particular case, the critical path is A, B, C, F, G, H. And we expect that it's going to take Chris 7.5 hours. I mean, if she worked from start to finish to get everything done, it would take her 7.5 hours. All right. So any questions on how to, once you identify the path, how to, you know, find the path duration and the critical path, etc.? Okay. So once you have, you know, your paths identified and how long it takes to get each one, then what you can do is you can put together a schedule. Now, so let me come back here. Well, I don't have my network drawn here, but for instance, activity B. So activity B here. If you recall, we could do activity B only after we finished activity A. So if we, finish activity A on 11/9, let's say in the morning, then we can start activity B on 11/9 in the afternoon. Okay. So again, once you put together your network, then you can actually put together when you think you're going to be able to start each task and when you'll estimate to end it. You can also assign resources, and this is what a project manager would actually put together that would coordinate activities and then be able to monitor the progress of the completion of the activities in the network. Okay, and I have shown the critical activities with an asterisk there. And the reason those are asterisked is again, if those slip, if those take longer, or if something happens that prevents you from getting them done in the estimated time that you planned, it's going to delay the overall project. Okay, so that is why they're asterisked. It's just to call attention to making sure that those are managed and to have contingency plans available in case they run over or they don't get done in time. So questions on the schedule? Okay, so this is problem 3.3 from the book, and you can see I have immediate predecessors, I have the time for each activity, and you can see I've drawn the network, and there are 3 paths through this network, and they're identified, and the critical path is the lowermost path, ACFH. It's 21 days long. And I also have here path slack. So what path slack is, it's just the amount of slippage that a path can have before it too becomes a critical path. So the path slack is going to be equal to the critical path minus the length of the path. So by definition, the critical path has 0 slack, because in this case, it's going to be 21 minus 21. For the first 2 paths, the path slack is the 21 critical path minus their duration of 19. And so you get a 2-day slippage that the path can slip by 2 days without it really affecting the overall duration of the project. Okay, so questions on this example? Okay, so now let's deal with probabilistic activity times. So before I do an example, I want to call to your attention these following formulas, because I'm going to show them in an Excel spreadsheet. First of all, you're going to be given 3 times for each activity. You're going to be given an optimistic time, you're going to be given a likely time, and you're going to be given a pessimistic time. So the optimistic time is what we're going to call A, the likely time is what we're going to call M, and the pessimistic time is what we're going to call B. So what we're going to do is we're going to take a weighted average of the optimistic, pessimistic, and most likely times, and we're going to try to create like a bell-shaped normal distribution out of those times. So we're going to give 1/6 weight to the optimistic and the pessimistic times, and we're going to give 2/3 weight, or 4/6, to the most likely time. All right, so the first step is you're going to convert those 3 estimates into one weighted average activity time. Then you're going to estimate an activity variance. The activity variance is going to be your pessimistic time minus your optimistic time squared divided by 36. Okay. So now for each activity, we have an average weighted time and we have a variance. Once we have this done for all the activities, we can add up all the average activity times to an average path time. And we can add up all the activity variances to get a path variance, just like it says in number 4. Once we have a path variance, if we take the standard deviation of it, or just take the square root of the path variance, we get the path standard deviation. And then as item 6 there says, we're going to use the z-table and calculate the z, or the average standard deviations away from the average path time that a certain date is. And so what we're trying to do is we're trying to estimate the probability that the path will be done by a certain date. And we can use the z-table to estimate that, or to find the probability. So item number 8 there, it says if we assume all paths in a network are independent, we're going to multiply all the areas or all the probabilities of each of the paths together to find the overall project probability. Okay? So I wanted to make these 8 steps explicit, and I'm going to go through each 8 of them in a minute with an example. But anyway, these are the 8 steps that you're going to follow to handle probabilistic activity times. And if you're somewhat savvy with Excel, it'll make your life a lot easier. But you don't have to use Excel. You can use, again, whatever you want, but just makes it a little easier on Excel. So any questions on these 8 steps? Okay, so let's do an example here. This is example number 21. And first, to do probabilistic activity times, you have to know how to draw a network. And so the first step we're going to do is we're going to draw the network. And you can see that we have 2 paths. We have the path AC, and we have the path BD. And then you can see for each activity, we're given an A, M, and a B. And A is the optimistic time, M is the most likely, B is the pessimistic time. Okay, so step number 1, you're going to draw the network and identify the paths. Okay, step number 2, once you've done that, what I would recommend is that you list your paths and do the analysis for the path. Okay, so you notice here I have AC activities. Instead of A, B, C, D, I have AC because AC is a path. Okay, so you can see for A, I have a weighted average activity time of 10. So where did this come from? This is the 9 plus 4 times the 10 plus 11 divided by 6. All right, I have the formula up here. It's a little small. But again, what I'm doing for activity A and C is I'm just taking the weighted average of each of those 3 times and coming up with one activity time that represents, all 3 of the times given. Then once I have the activity times, I'm going to add them up to get the path time. So AC is the path, 10 plus 10 is 20, so the path AC will take 20, let's just say 20 days. Once I have the path time, then I need to calculate the variances of each activity. So this is the B minus A squared over 36. So for A, if I took 11 minus 9 squared over 36, I'd get the 0.11. Same thing with C. If I took 11 minus 9 squared over 36, I'd get the 0.11. If I add up the variances for each activity, I get a path variance of 0.22. And if I take the square root of this 0.22, I get a 0.47 standard deviation of the path. Now, this particular problem wanted to know what is the probability of completing this project in 22 days or less. All right, so this 4.24, and let me write this up here. The Z is going to be the 22 minus the average path length of 20 divided by 0.47 of the standard deviation is 4.24. Okay? So where that 4.24 came from, it was just, again, you're going to be given the 22. It wants to know what's the probability that the project will be completed in 22 days or less. So you're going to do the 22 minus the 20, that's the average path length, divided by the standard deviation of the path, gives you a Z value of 4.24, which is basically 100% probability. There's a 100% probability that you'll have path AC completed by day 22. Now, for activity BD, you're going to do the same thing for that, but the Z value for BD is just going to be the 22 minus, and you can see that BD has an estimated duration of 18, but the variance is a lot greater than for AC. So if we calculate a Z value for path BD, we get a Z value of 1.78. So that means that 22 is 1.78 away from the average path length. So if you use the Z table, or again, if you want to use Excel, you can use the equal norms dist. You can find these areas. So the area that corresponds to a Z value of 4.24 is basically 1, and the area that corresponds to a 1.78 is 0.96. If we multiply 0.96 times 0.99, we get an overall probability of 96%. So the probability that these two paths will be complete by day 22 or less is 96.3%. Okay, so questions on this particular example? Okay, the last two slides have to do with crashing. And again, as you recall, crashing is shortening the overall length of the project by adding resources. So what we need to do to shorten the overall length of a project is we need to shorten critical path activities. If we shorten a non-critical path activity, it's not going to shorten the overall project. It's just going to shorten that path. So the first thing to remember is we're only going to focus on critical path activities. Those are the ones we're going to focus on. And then the second thing to remember is if you have a choice between shortening various critical path activities, you're going to pick the cheapest one. All right, because if you can shave a week off for $500 or shave a week off for $200, why would you spend the $500? You'd want to spend as little as possible, as long as you could shorten the project by a week. Okay, so this is example 18 from the end of the chapter, and it gives you the original times, how much you can crash to. So the crash time available, this is equal to the time minus the crash to. So the 6 minus the 5 is the 1. Okay, the 8 minus the 6 is the 2. So instead of just telling you how much you could crash it, it just gives you total time minus how much you could crash it to. So you have to calculate the crash amount available. So for activity A, you can take 1 week off of it. All right, that's basically what crash available means. You can only crash it for 1 week. And then in terms of the costs, you have to calculate those. Crash per day is just going to be the crash cost minus the normal cost divided by how much crash is available. All right, so I have the formula over here, but this is the second to the last column that's how much it costs per day to crash each of these activities. Okay, so you have to do a little bit of work to translate some of these data into something meaningful that you can use. So any questions on where I got crash available and how much it costs per day to crash? Okay, so the next thing you have to do is you have to identify the paths. So you can see that this network, there are 3 paths. There's AD, there's B, and there's CE. If you look at these 3 paths, you can see that path CE is the critical path. All right, so if you're going to shorten this path from 12 to 11, you have to shorten either C or E. All right, so what I have here, so if you look, if you don't crash anything, 0-day crashed. C, you have CE is 12, that's your longest path. So that's where you want to focus, crashing your activities. So if I want to go from 12 to 11, and if I want to crash 1 day off, I'm going to look, then I come up here and I look at, I can take a day off of C, and I can take a day off of, or I can take up to 3 days off of E. But C is the cheapest one. C is only $100 per day. E is $200 per day. So I'm going to pick C. I'm going to crash C once to go from 12 to 11, and it's going to cost me $100. Okay, so that's what I did, is I focused on my critical path, and I focused on the cheapest activity in my critical path to crash. So by crashing, or for spending $100, I have shortened activity C from 4 days to 3 days. All right, so any questions on how I went from 12 to 11? Okay, so notice after I did the first week, now I have 2 critical paths. I have path CE is 11, and I have path AD is at 11. So to shorten this down to 10, I have to take, crash 1 activity from each path. C is no longer available. It was only available to crash once, and I already crashed it. So that one's gone. So to go from 11 to 10 on CE, I'm going to have to go with E. I can use E 3 times. It's going to cost me $200 each time. So to crash CE from 11 to 10 days, I have to spend the $200. I also have to go on AD, because that one is at 11 days also. So if I look at A and D, A is $100, D is $150. So I'm going to crash A. It's the cheapest one. And so again, to go from 11 to 10, I'm going to spend an additional $300 and, crash activity A and E. Okay, so everybody okay with moving down now to 10 days? Any questions? Okay, so this particular example wanted us to crash 4 days. So now you look, after we crashed down to 10, we still have 2 critical paths. So if we want to go to 9, then we have to crash another one off of CE. And again, C is no longer available, so we can only crash E. And then to go down from 10 to 9 on path AD, A is no longer available. It was only available to crash 1. So we're going to crash now D for 150. And so now to move from 10 to 9 weeks, we have to spend another $350. And then finally, to go one more week, to go from 9 to 8, again, we're going to have to crash D and E, another $350. So the total cost to cut 4 weeks off of this project is $1,100. So this is an example. There are actually two types of crashing problems. The first type is when it tells you how many weeks or how much time to crash. So this is an example of that kind. You just crash, again, only activities on the critical path and the cheapest ones that are available. Okay, so questions on this example? Okay, the last example is when you are not given an amount of time to crash. It just asks you to crash it to an optimal. And so probably to help you think about this example, let's just imagine that this is the length of a project and this is cost, okay? So on the y-axis is the cost, okay? And on the x-axis, let's just say this is the length of the project, okay? All right, so as you can see here in this particular example, we have some indirect costs, or we have some costs that vary linearly with the length of the project. All right, so the longer the project is, the more these indirect costs are going to be. All right. Now, you can try to save money by shortening the length of the project, right? So if you shorten it, you're going to save indirect costs. But when you shorten it, now you're going to spend crashing costs. All right. So this bottom line here is the cumulative crashing cost. And then this top one up here is the indirect cost. All right, so if you look at a total cost, it looks something like this. Okay, so this U-shaping line is your total cost. And so with this one, this type of problem, what you're going to do is you're going to keep shortening and shortening and shortening, and you're going to come down this total cost curve until you hit the minimum. There's only one minimum, and you will know you hit it because then you're going to start going up in cost. All right, so you're going to crash. You're going to keep crashing until these total costs go to a minimum and you start seeing them go back up. And that is going to tell you what your length or how much to crash. All right, so that's kind of the conceptual overview here. So let's go back to this example, the one that we just did, and let's just say now we have indirect costs of $150 per day. All right, so we still have 3 paths. As you recall, CE is still 12 days long. So if we don't do anything, let's just say we don't crash, we don't do anything, we will have indirect costs here of 12 days times 150 per day, or $1,800. So basically right here, this is $1,800. We're way over here at this and just indirect costs. We haven't done any crashing. So if we want to take 1 day off, all right, so again, we know that we're going to have to, CE is our critical path at 12 weeks. So if we take the cheapest activity, which is C, it's going to cost us $100. Our cumulative cost with crashes is $100. So we spent $100, but we've saved $150 because notice the indirect costs now are 11 times 150 or $1,650. So our total cost has gone down by $50. It was $1,800 when we didn't crash, and now it's down to $1,750. So again, we're coming down this total cost curve. And so what we do is we just keep going until we find a minimum. So you can see if we look at 2 days crashed, this last row here. We know that we have to crash A and E. It's going to cost us an additional $200. Cumulatively, it's going to cost us $300, but we're going to save another $150 on our indirect costs. So our total cost now is going to be $1,800. So now you see we're at $1,750. We've passed the minimum, and now we're starting to go back up again. So the optimal amount of time to crash is $1,750 with 1 day crash. That's where we had our minimum total cost. And so the answer to this question is the optimal crashing plan is to crash 1 day. We're going to crash activity C for a total cost of $1,750. Okay, so questions on trying to figure out an optimal crashing plan? Any questions on anything that I've talked about this evening? Any questions about the class or what's due this weekend? Okay, so just as a friendly reminder, your Chapter 3 homework will be due this Sunday. And next week we will have the final exam. And it'll cover the chapters that we've covered since the first exam. Okay, there is a question about the slack time. So again, the slack is just the difference between, for the path slack, is just the difference between the critical path time and a non-critical path time. All right, so it's just the difference. So you have to find all the paths. You have to find how long each of them are. The longest path is your critical path. The difference between that and the other paths is the slack. Okay, and that's slack, if you just think about it as slippage, it just is the amount of time that that path can slip without making the overall project late. Okay, any other questions? Well, we have only one more week of the semester, and I imagine all of you are going to miss ops. So I hope you all have a good week. If you do have any questions on the homework, feel free to post them in the course or email me directly. And then I'm in the process of having the exam dates changed so that on Monday will be the first day you can take your final exam. You'll have until next Saturday. I have not made up your final yet, so I don't know how many questions or anything there is, but I'll post a note once I have made it up and let you know more information. And it is a proctored exam, so you'll all have to get a proctor or use your remote proctor for it. The exam is open book, open notes. You can use your PowerPoint slides. Again, you won't see anything that is different from either what we've talked about or what you've had on your homework, okay? You can also use Excel or you can use a calculator. Okay, so I'm going to let you guys go, so have a good week, and this will be the last time we chat on the phone, so I've enjoyed having you guys as a class. I think you're wonderful, and I wish you all the best with the course and finishing your Troy University studies. There is a question. There was the date on the syllabus indicates that the final exam is next week. So what I'm in the process of doing is changing the date of the exam so that it's consistent with the syllabus. So the final will be next week. Okay? And this will allow you to spend this week on Chapter 3, get Chapter 3 under your belt, and then next week you can just worry about taking the final and then finishing your projects. Okay? All right, everyone. I hope you have a great night, and please let me know if you have any questions. Take care. Bye-bye.